Thank you for standing by. As a reminder, today's call is being recorded. If you have any objections, you may disconnect at this time. Please stand by.
Good afternoon, and thank you for joining us for today's NASA Science and Technology Media Teleconference for NASA's Commercial Lunar Payload Services, we like to call that CLPS, initiative. I am Karen Fox with NASA's Office of Communications, and today's teleconference will cover the NASA Science and Technology that will soon launch aboard Intuitive Machines' second flight to the Moon. IM-2 is scheduled to launch on a SpaceX Falcon 9 rocket from NASA's Kennedy Center no earlier than Wednesday, February 26th. That's tomorrow. Our speakers today are Joel Kearns, who is the Deputy Associate Administrator for Exploration with the Science Mission Directorate at NASA headquarters in Washington, D.C., Niki Werkheiser, the Director of Technology Maturation in the Space Technology Mission Directorate at NASA headquarters, Jackie Quinn, Polar Resources Ice Mining Experiment 1. Short version of that is Prime 1, which is what you'll hear referred to today. She's the project manager for that at NASA Kennedy in Texas. Daniel Cremons, who is the LRA Deputy Principal Investigator at NASA's Goddard Space Flight Center. That is the Laser Reflector Array, shortened to LRA. Bethany Ehlmann, the Lunar Trailblazer Principal Investigator at CalTech in California. Trent Martin, the Senior Vice President of Space Systems at Intuitive Machines, and Thierry Klein, who is the President of Bell Lab Solution Research for Nokia. Each one of them will give short remarks to kick us off, and after they speak, we will be answering media questions. You can always press *1 to get into the queue if you are on the line. And for now, I will hand it over to Joel Kearns.
Thank you, Karen. Well, good day, everybody, and we're going to have this team today to tell you about a really exciting time coming up for science and technology on the moon, as well as commercial activities. As Karen said, Intuitive Machines Corporation is getting ready to launch their Intuitive Machines IM-2 lander mission to the moon later this week. That will include NASA science, some substantial NASA technology, and also commercial activities. In addition to that, on that flight, Intuitive Machines will take several small satellites that will either do their work in lunar orbit or at other destinations in space, And today you'll also hear from our Lunar Trailblazer project principal investigator, Bethany Ehlmann, to talk about her science satellite, Lunar Trailblazer. This is all being done under the Commercial Lunar Payload Services Initiative, which is part of the United States Artemis campaign. I want to point out that landing on the moon is very challenging. It's a lot tougher than landing on Earth, where we have the advantage of air and we can use wings and parachutes and things like that. Bluntly, to get down to the surface of the moon, you have to ride a rocket all the way from orbit down to the particular place you want to land at the particular elevation and make sure you land and be able to set your cargo down safely. So we have this is a very sophisticated and exciting mission with many of these different activities upcoming that you're going to hear about now from this team. And it is just another example of NASA science and NASA technology for the benefit of the United States. I'm going to be turning over now to Niki Werkheiser from our Space Technology Mission Directorate. Niki?
Hello, everyone. Thanks, Joel. How exciting to be here together for this L-1 day briefing. I am absolutely beyond thrilled to have the opportunity to share a brief overview of our remarkable technology demonstrations that we have aboard the IM-2 mission. So I am the Technology Maturation Director for our Space Technology Directorate at headquarters, and just as the title says, I am passionate about what we do because it's these space technology investments that we make today that will really enable the missions of the future by delivering the cutting-edge technology that defines American leadership in space exploration for many years to come. Of course, today we're here to talk about IM-2, which is carrying pivotal in-situ resource utilization, communication, and mobility demonstrations, including NASA's Prime 1 and 2 commercial tipping point technologies that were enabled through industry partnerships. I'll take a minute to share that this IM-2 mission is particularly special for us, as it's largely dedicated to lunar technology demonstrations that are really foundational to creating that U.S.-led lunar infrastructure that we all need. First, I want to talk a bit about NASA's Prime 1, which is capable of identifying and quantifying volatiles that are found in the lunar regolith. This is a really important technology demonstration for NASA because it's going to provide important data to help us better understand the moon's surface and help inform and minimize the risk to our future ISRU missions. Jackie Quinn is going to share more about this exciting demonstration next. In addition to Prime 1, the IM-2 mission will carry 2 tipping point technology demonstrations, the Intuitive Machines Deployable Hopper and Nokia's Lunar Surface Communication System. Before you hear more details on these state-of-the-art demonstrations, I do want to share just a bit of history as to why this mission, as I mentioned, is very particularly special to me. As novel as these technologies are, the layers of collaborations across NASA and industry are equally as novel and exciting because we were able to actually combine the CLPS IDIQ task led out of SMD for the Prime 1 demonstration and the 2 tipping point partnerships led out of Space Tech for the 2 enabling commercial demonstrations to insert a whole additional CLPS mission into the sequence. This is very exciting to me because these payloads are a product of some of our earliest technologies selected through NASA's Lunar Surface Innovation Initiative, which was established in 2019. And the whole idea behind that initiative was to do exactly what we're doing here, to work across NASA and industry to ensure that the novel lunar infrastructure technologies are developed and proven in time to become institutional capabilities that we can infuse into missions. And that is why every one of these robotic missions are absolutely key in maturing these technologies now. I am proud to say that this is a very busy and exciting time in lunar and soon Mars exploration, and we are anticipating an even busier cadence to come. So with that, I will turn over to Jackie Quinn to share more on Prime 1.
Good morning, everyone. I'm excited to be here today to talk about NASA's Polar Resources Ice Mining Experiment, or Prime 1. This experiment marks a significant milestone as it will be the first robotic drilling activity conducted in the moon's South Pole region. It's a crucial step towards understanding and harnessing lunar resources to support future exploration. Prime 1 will land near the moon's south pole, where it will drill into the subsurface and analyze for frozen gases released into the lunar vacuum. These gases could serve as a valuable resource. The payload, Prime 1, consists of 2 key instruments that will work in tandem. The regolith and ice drill for exploring new terrains, or Trident, was developed by Honeybee Robotics, a Blue Origin company. Trident will dig 3 feet into the lunar regolith to gather samples and measure soil properties. The second instrument is the Mass Spectrometer Observing Lunar Operations, or M-SOLO. M-SOLO is a commercial, off-the-shelf mass spectrometer developed by Infocon and made suitable for spaceflight at the Kennedy Space Center. M-SOLO will analyze any gas released from the drilled samples, looking for the potential presence of water, ice, or other gases trapped beneath the surface. Prime 1's ability to drill and analyze samples simultaneously provides key insights that will shape the future of lunar resource utilization. By gathering critical data on how lunar soils behave and how we can drill and analyze remotely, the experiment will optimize in situ resource utilization, which is the process of using lunar materials to produce key essentials like breathable oxygen and rocket fuel. This is an exciting payload because it's not just about what we find, it's about what we learn along the way. Prime 1 will pave the way for a sustainable human presence on the Moon, providing the first key set of engineering and science data about the lunar South Pole region. Thank you, and with that, I'll hand it over to Daniel.
Hi there, I'm Dr. Daniel Cremons from NASA's Goddard Space Flight Center, and I'm the Deputy Principal Investigator for the Laser Retroreflector Array Instrument, or LRA. LRA is a completely passive instrument. It consists of a hemispherical array of special glass prisms called retroreflectors, which return light back towards the illumination source. A similar phenomenon is used in road markers to make them shine brightly under a car's headlights. It's a small payload. It only weighs 20 grams, which is about the weight of a AA battery, and it's only 2 inches in diameter, which is about the length of a matchstick. On the Athena lander, LRA acts as a precise marker of the lander position that will be visible under illumination from a laser ranging system on board either an orbiting or a landing spacecraft. As I said before, LRA requires no power, thermal control, or interaction with the lander other than the mechanical interface, which allows it to be used for decades on the surface during both lunar night and day. LRA will be used to locate the lander on the surface in 3 dimensions with very high precision. It can measure changes in the lander position over long time periods, including decades, and determine the precise orbit or landing trajectory of a spacecraft illuminating it. This LRA will join several already on the surface to build up a network of precision landmarks that are being targeted presently by the Lunar Orbiter Laser Altimeter, or LOLA, on board the Lunar Reconnaissance Orbiter, and can also be used by any future orbiter or lander. The LRA team is very excited to be a part of the Intuitive Machines IM-2 mission. Thank you so much.
Thanks so much, Daniel. Next up, we have Bethany Ehlmann.
Good afternoon. I am delighted to be speaking to you about Lunar Trailblazer, NASA's small satellite mission to understand the form, distribution, and abundance of water on the Moon and add to our insights about the water cycle on the Moon and other airless bodies. We launch along with Intuitive Machines, sharing the rocket as one of the spacecraft on the ESPA ring for secondary payloads. We then separate a little less than an hour after the launch, turn on, and then use our propulsion system to begin making our way to the Moon over an approximately 4-month journey using low energy trajectory and gravity assists from the Earth, Moon, Sun system. After lunar orbit insertion, we circularize into a 100-kilometer polar orbit that allows us to look at that makes every corner of the Moon available to us for us to look at in our water search, with particularly frequent coverage over the polar regions. Between crews and our science mapping at the Moon, the duration of our operations phase is anticipated to be 2 years. We carry 2 instruments on board, the High Resolution Volatiles and Minerals Moon Mapper, or HVM Cubed, which is built by JPL, Jet Propulsion Laboratory, and funded by NASA. HVM Cubed is our water sensing instrument. It's an imaging spectrometer that uses the fingerprints of water in the infrared wavelengths to differentiate water ice from adsorbed water from water trapped in minerals. Our second instrument, the Lunar Thermal Mapper, is provided by the University of Oxford and funded through a partnership with the United Kingdom Space Agency. LTM measures temperature of the lunar surface at the exact same time that the water measurements are being made, thus allowing us to really understand where there's water, why, whether it changes with time and temperature. HVM Cubed and LTM acquire data simultaneously of water composition of the surface, that is mineralogy, and temperature. And these will be the highest resolution data sets of these parameters collected to date for select regions of the moon that are of high interest for science and future exploration. So collectively, our data set is going to answer fundamental questions about water on the moon and provide maps for the next generation of landed lunar robotic and astronaut missions. Thank you.
Thank you so much.
I will hand it to Trent Martin.
Yeah, I cut you over, sorry. Yes, Trent Martin is next with Intuitive Machines.
Great, thank you. This is Trent Martin. I'm the Senior Vice President of Space Systems for Intuitive Machines. We're excited to be preparing for our second launch to the moon, hopefully tomorrow. It is a completely commercial mission. We purchased the entire Falcon 9 and in fact, sell ride shares to the 3 satellites, including Lunar Trailblazer, on our way to the moon. So the 3 satellites run along with us on the trajectory out to TLI. The vehicle is currently rolling out to the pad. If you happen to be near KSC, or if you can see a video of it, you can actually see the Falcon 9 rolling out to pad 39A right now. Everything is ready to go. Today, I was going to talk to you a little bit about the hopper. The hopper, we call it the hopper. Officially, it's called the Intuitive Machines Micronova Hopper. It is named after a software pioneer, Grace Hopper. So we call the vehicle Grace. The intent is that once we land on the surface, we hop off of the main lander, off of the Nova C. We do 5 hops to demonstrate the technology of this hopping capability to hop down into places where wheeled vehicles cannot go. As part of the demonstration, we agreed with NASA that we would put on a camera system and prove out the technology. Subsequent to getting that agreement with NASA, we added a commercial pyrometer through the German Space Agency in coordination with the Technical University of Berlin, as well as a pulley water snooper, a neutron spectrometer in coordination with a company in Hungary called Pulley Space. And we have subsequently worked with the European Space Agency to ensure that we have the ability to publish that data as part of the demonstration mission that we're doing with ESA. So you can see that we took this commercial approach to a whole different level and partnered with multiple agencies as well as commercial companies to come up with what our principal investigator, Mark Robinson, scientific investigator Mark Robinson, calls the coolest space vehicle ever, to hop down into a permanently shadowed region that is nearby the landing site that we hope to land at, which is around the Mons Mouton region of the South Pole, about 160 kilometers from the South Pole of the Moon, 5 degrees closer than our landing on our IM-1 mission. And with that, I will pass it over to Thierry Klein from Nokia Bell Labs.
Thank you, Trent. Good morning, everybody. I'm Thierry Klein, President of Bell Labs Solutions Research at Nokia. Throughout our 100-year history, we've had a number of forays into developing advanced communication solutions for space, and we're really excited to be part of the Intuitive Machines IM-2 mission now. And our goal is to take the cellular technologies that we develop and deploy on Earth that connect billions of devices and people every day, and take those same technologies and prove that we can deploy them in space and bring them to bear on mission requirements for uncrewed as well as crewed missions in the future. So our goal for the IM-2 mission is to deploy and operate the first cellular network on the moon. It's based on the standard technologies that all of us use every day, but we've completely reconceptualized the system to make it, to adapt it for the particular requirements of the mission, focusing on size, weight, power optimization, as well as an autonomous network deployment. Our network is mounted on the Athena lander, and we're connecting two payloads, the Micro Nova hopper that Trent talked about, as well as the MAP rover from Lunar Outpost. And by providing that cellular technology, we will establish high-capacity data links between the rover, the hopper, and the network on the lander, facilitating image, video transmission, as well as command and control capabilities. And we're really excited to be partnering with NASA through the Tipping Point program, as well as the partners at Intuitive Machines and Lunar Outpost. And we very much look forward to launch and deploying this network on the moon. Thank you.
Thank you so much to all of our speakers. We are now going to open it up for questions to the media. Reminder that you can press *1 to get in the queue if you are on the line. If you know who your question is for, go ahead and say it, as well as identifying yourself. And on our side, a reminder to our speakers to please say your name before you answer a question to make it clear who is speaking. And in the meantime, on to the first question, which is from Marcia Dunn with the Associated Press.
Yes, good morning. Two questions for Joel, please. I know the original contract for this mission was $47 million to take up the NASA payloads. Is that still a good number, or has it gone up? And this will be the first time 3 spacecraft are heading to the moon all at the same time, 2 of them under your program. I mean, talk about how important, exciting, thrilling this is to have the moon just ready to accept all these visitors. Thanks.
So the answer to the first question, Marcia, and this is Joel Kearns from NASA Science, is the current value of the contract that we have with Intuitive Machines for the NASA cargo through CLPS that they'll deliver to the lunar surface is $62.5 million. And that has changed from a variety of changes that NASA made over the years, one of which, for example, was amending the contract so that once Intuitive Machines has the temperature data from the Micronova hopper, under that contract value, we have the opportunity to buy that temperature data from Intuitive Machines, which is kind of an example of us not paying for a piece of equipment, but actually paying for unique information that's going to be made available because of this particular commercial mission. So there were a number of changes we made since the contract was originally awarded, I think, in 2020, that have increased its value up to $62.5 million to deliver what we call to do the Prime 1 task order. And to answer your second question, I'll tell you that it's an incredibly exciting time, and it really shows the interest internationally and from commercial organizations and from governments in moving out into the space frontier, and particularly the moon, as we get ready to move even further on the way to Mars with people and additional robotic missions. As you said, there is one CLPS-sponsored contracted provider in flight right now in orbit around the moon. You're hearing today about this outstanding, sophisticated mission, which is science, technology, and commercial activities that is getting ready to take off to the moon. You know that there's the Japanese iSpace commercial lander also on its way to the moon, and we expect later this year there'll be additional missions, both from the United States and some of our partners. So I think it really shows the incredible interest in pushing out into the space frontier, developing the technologies we need robotically and for future human missions, getting ready to push on further for Mars, but also along the way conducting really high-value science, which will not only put the United States in a very good position in the future, but also will help us do an even more outstanding job at the human missions that are coming up in the near term to the moon.
Thank you so much, Joel. Moving on to our second question, which is from Gina Sunseri with ABC News.
Trent, this question is for you. How agile have you had to be? You learned a lot from Odysseus, and you made improvements to Athena. So how agile do you have to be when you're with all these commercial clients, and that's what you really need to expand space exploration?
Thank you very much for the question. This is Trent. our team is an extremely agile team. We have a group of people that include engineers and scientists that worked years and years at NASA or NASA contractors, and we couple that with a team of younger engineers who maybe aren't as steeped in the processes that you would get in traditional aerospace. The way that our company works is we take all the processes that we know you have to do to fly things in space and be successful, and we keep those. And for the processes that maybe have slowed down some of the traditional aerospace, we try to minimize those as much as possible so that we can move very quickly. You can see that we're 1 year away from launching the Odysseus spacecraft. We're about to launch the Athena spacecraft with changes that have been implemented to adapt for any issues that we had on that first mission, any lessons learned that we had. And of course, I'm sure we'll learn from this mission as well, and we'll have to adapt and adjust and overcome any issues we have with that. That's the way of the space business right now. The teams have to be agile, they have to be adaptable, and they have to be ready to take on a new challenge and move quickly, in particular in a new market like the nascent lunar market that we find ourselves in right now.
Thank you so much for that answer. We are going on to our next question, which is from Will Robinson-Smith with Spaceflight Now.
Hi, good morning. Thanks for taking the time to talk with us today. A couple of quick ones for Trent Martin, if I may. In your opening remarks, Trent, you mentioned that you're hoping that the launch can move forward tomorrow. Can you say if there are any issues being worked relative to the Nova-C lander specifically? And then, you know, in the realm of this being a very commercially robust mission, given that the IM-2 lander, you know, only has so much mass, you're able to have additional payloads like the Lunar Trailblazer. How did Intuitive Machines and NASA go about figuring out what additional secondary rideshare payloads would be integrated onto this mission, and then, you know, maybe looking at IM-3 down the road? Like, what's kind of the process of deciding who's going to share the rocket with you guys? Thanks.
Okay, thank you for the question. As for launch timing, we're expecting a launch tomorrow. We are not currently working any issues with the Nova-C. The Nova-C is buttoned up and ready to go. We're obviously working with SpaceX, our launch provider, to get the vehicle out on the launch pad upright and perform our wet dress test that we hope to do sometime later today. As far as commercialization, the basic commercial approach is that commercial companies like Intuitive Machines are identifying a mission that we have to the moon. We then work with CLPS and with other entities within NASA to identify other things that might want to fly along with us. For instance, in this particular case, we bought the entire Falcon 9 rocket. We had up to 900 kilograms of available mass that could go to translunar injection. Lunar Trailblazer was ready to go to the moon and just needed a ride. And so we worked with NASA to write a separate contract to fly Lunar Trailblazer to the moon as a rideshare on this mission. And that process has been fairly seamless. We assign a payload integration manager for Lunar Trailblazer. They work directly through us and then on to SpaceX. And so that's how we do things on the rideshare side. On the Nova-C side, we work to sell commercial payloads, and we've sold multiple commercial payloads on this mission, including Lone Star and the Yaoki rover, which is a Japanese rover. And Lone Star is a commercial company here in the United States that is looking to put servers on the moon. So there, and then of course we have our partnership that we have with Columbia, and we're putting a payload of Columbia's on the second mission. We flew on the first mission as well, and a partnership with them for these first two missions. It's a changing world. The commercialization approach, I think, is the right way to go as we move forward out into the solar system. We've proven that it works in low Earth orbit. We're now proving that it works at the moon and in cislunar space, not only with missions like our CLPS missions, but also our missions like our Near Space Network Services, where we provide a commercial service of data relay and position navigation and timing. through to the NASA SCAN organization as part of our Near Space Network Services contract. I think it's just the way of the future.
This is Joel Kearns from NASA Science. I want to add that NASA has a standard process for how we buy ride shares for smaller satellites, which will ride as, say, secondary payloads on another major mission. We do that through our Launch Services program here at Kennedy Space Center. In this particular case, we did it somewhat differently because we already knew from our CLPS activity for Prime 1 that Intuitive Machines would be going to the moon, and it was a natural fit for Lunar Trailblazer to be part of that mission as long as Intuitive Machines had that capacity on the Falcon 9 mission that they had purchased, and it made a good fit.
Thank you so much, Trent and Joel. A reminder that if you want to ask a question, you can press *1 to get into the queue. Next up, we have Alexandra Witze with Nature Magazine.
Hi, thanks for taking my question. This is for Jackie Quinn with the Prime 1 drill. Could you just talk a little bit more about kind of what you're expecting the lunar regolith to look like? Like, what is the texture and the temperature of that stuff you're going to be drilling into, and how is that going to change as you go deeper? And is there a point at like where it gets so cold, do you think you won't be able to penetrate anymore?
Hi, good morning. Yes, so I'll talk about temperature first. We do have orbiting assets that give us an indication of the temperature at the location that Intuitive Machines is targeting. It is slightly above 100 Kelvin at the surface. There is some thermal modeling to suggest that the deeper you go, there's a sweet spot at the subsurface where it's cooler and then it gets warmer as you go deeper. So we're not expecting a huge thermal difference as we leave the surface of where the lander sets down and penetrate the 3 feet or roughly 1 meter below the surface. The texture of the soil or the lunar regolith is an unknown at this point. We do have samples that were brought back as part of the Apollo program. However, those samples were not from the South Pole region. In general, the lunar regolith is very, what's the word I'm looking for? It's abrasive. It has no environmental degradation that happens to it other than other impact activities. So it's very sticky and kind of like I've had lunar regolith. It's not like anything I've ever experienced here on Earth. It's just very abrasive. It's the best. There's nothing worn about it. So it sticks to everything that it encounters. It has to do with the abrasiveness as well as the charge that the particles can acquire on the surface. So I think those were the two questions you were looking for. Was there another one that I needed to go back to?
I think she is. Oh, no, Alex is still there.
Yeah, no, that's great. Thank you.
You're welcome. Fantastic. Thank you, Jackie. Thank you, Alex. Moving on to Irene Klotz with Aviation Week, please.
Thanks, Karen. I have a couple questions. First of all, for Trent, I believe that Intuitive Machines has a 4-day launch opportunity that opens tomorrow and then I guess would run through March 1st. Is that still accurate? And if you can just verify what the targeted launch time tomorrow is. And then for either Joel or Trent, regarding the IM-1, was the company able to receive its full payment from NASA for that mission despite the complexities and limitations in the science operations after the landing? And also, if you're able, Trent, to just maybe talk a little bit about specifically what's been changed to ensure that the landing mishap doesn't repeat. Thanks.
Great, thanks for the question. Yes, we do have a 4-day launch window that opens up tomorrow evening, early evening tomorrow. SpaceX will broadcast the exact time once we get through our wet dress tonight. The question for payment, I may leave that one to Joel, but I will tell you that we pulled down as much data as we could possibly pull down on IM-1. We negotiated with NASA on final payments. The payment, the way the contracts work is it's based on data that you're pulling down, and so obviously if you don't get all of your data for all of the instruments, there's some reduction in the payment. But if you get some additional data, you might be able to negotiate on your final payment. And then on changes that we made, we identified 85 specific things that didn't go like we wanted to on IM-1, 10 of which had to be replaced before we went into IM-2. We have fixed or changed all 85 of those items. The most obvious one that we had to change was our laser altimeter. On the first mission, we did not land upright, primarily because our laser altimeter was not working as we expected. The laser altimeter worked great. The cabling that we had built for it did not work as expected, and we had to upgrade that. It was an easy thing to identify. Once we identified it, we've made that change. I will say we have fired that laser not only in our facilities in Houston, but also once we got down here at the Cape, so we're very confident that the lasers will work this time. The second thing that caused us some issues on the first mission was our orbital determination on the way to the moon and determining our exact position. At the time on IM-1, we coordinated with the Deep Space Network and were able to get some additional data, which helped us achieve our goal of landing on the moon. This time around, we better coordinated with DSN, and we're going to compare that to our commercial network that we use to determine our location in space. And hopefully with the gold standard of DSN comparing to our commercial network, we'll be able to better determine our location in space this time around. And of course, there were many other things that we adjusted for this mission. We're pretty confident those things won't happen again. Spaceflight is hard though, and something will happen, of course. We prepared ourselves, including our mission teams. We have 3 round-the-clock teams that operate, and then we have a 4th team that operates now around the clock as well to deal with any anomalies that come up so that the mission ops team can continue their minute-by-minute operations while any anomalies are addressed by a separate team outside of the control room. Thanks.
This is Joel Kearns from NASA Science. To address your question, what I'll say is that although I don't have the numbers here with me, we eventually negotiated with Intuitive Machines a final payment that was relatively close to what we had projected that they would earn for the mission, but for very different reasons. One is that the final total amount that we negotiated with Intuitive Machines was based on the criteria we had set for them before the mission, which did not require them to satisfy every single objective that we had tasked them to do during the mission as part of their final payout. But in addition to that, it turned out, because of the nature of the landing, when the lander was on its side, we had the opportunity to gather from them some data we didn't expect to get during the mission. For example, there's a phenomena we look for on the moon called multipath radio phenomena, which is that radio waves can bounce off of the surface of the moon or in some of the local geological features of the moon. And although this has been theorized, and in some cases some very limited measurements have been made, it turned out that because of the IM-1 Odysseus, because of the orientation it was on the surface, it actually was subjected to a lot of multipath propagation during its mission on the surface. We actually at NASA found that quite valuable to get that data. So as part of the finalization of the contract for Intuitive Machines 1, we purchased a lot of data from IM about multipath, which we are now examining within NASA to see how to apply it for future moon missions. And that was one of the reasons why Intuitive Machines at the end earned substantially what we had projected they would at the outset of the mission.
Thank you so much to both Joel and Trent. Our next media question comes from Josh Dinner with Space.com.
Hi, thanks so much. My first question is for Bethany. I'm wondering about the Lunar Trailblazer's remote sensing data and how it's going to complement Prime 1's in situ measurements for the water ice on the surface. And then also one quick for Joel, if you could talk about the importance of IM-2 and the CLPS initiative for, particularly in preparation for Artemis crewed missions. Thanks.
Yeah, this is Bethany. Our data are going to get the form, distribution, and abundance of water at the surface for multiple key regions of the moon. I believe with the timings of things that Prime 1 will collect its awesome data set in situ at the surface on one point of the moon, basically sooner, ahead of time. So that will be a great data set, and then when we combine it, and then we will later get a map with Lunar Trailblazer of like what the rest of the site looks like in and around the drill hole. So I think what's really important is that will let us contextualize and extend the findings of the Prime 1 mission to what we might be able to see in other parts of the moon, using what we learn from those results from the ground, and then combining it with the properties that we see from Lunar Trailblazer from orbit to really start to understand, well, why? Why are we seeing this there, and are we likely to see it on the other side? So it's really, I think, powerful for linking those data sets.
This is Joel Kearns from NASA Science. Recall that we're using CLPS, or Commercial Lunar Payload Services, to really tap into the entrepreneurship and technical innovation of companies in the United States to really build up this capability in the United States to routinely go to the moon, to bring robotic cargo to the moon. And what this does is it lets us not only do initial studies ahead of the human landings at the South Pole of the moon, but it allows us to send these robotic landers with their scientific and technical cargo to locations all around the moon. You notice that there are a number of CLPS landings that won't go to the South Pole of the moon because they'll take unique data from other parts of the moon. It allows us to land cargo in places perhaps we wouldn't send the initial crewed explorers as we're getting ready to send humans to the South Pole of the moon. And certainly we gather from the strategic experiments, whether they're science or technology, that we put on these robotic landers, we're gathering data either to answer scientific questions that are longstanding or to test technology and test engineering approaches that will later benefit crewed missions to the moon, whether they're on our human landing system vehicles or their habitats that are on the moon or their transport systems that will go to the moon. So I've kind of answered that in general, but because of the work there that CLPS will do before astronauts get there, in parallel with astronauts at places other than we will send astronauts, it's incredibly valuable to our overall Moon to Mars exploration effort to push humanity out into the solar system. And I think at least one other person has a comment they wanted to make.
Yeah, thanks, Joel. This is Thierry Klein from Nokia Bell Labs. I would mention that beyond the IM-2 mission, we have also announced that we're partnering with Axiom Space to take the same cellular technology and integrate it into their next generation AX-EMU spacesuits. And this would be demonstrated as part of the Artemis 3 mission to show that we can, again, take the same cellular technologies, provide mission-critical communication now with voice, video, and data and telemetry transmission at extended ranges during EVA activities. Thank you.
Thank you so much to everybody for those questions. Our next question comes in from Jeff Faust with Space News.
Good morning. Two questions. One for Trent. If you do launch tomorrow evening, when's your expected day and time of landing on the moon? And does that change if your launch slips later in this 4-day launch period? And for Jackie, is the Prime 1 drill, are you able to use that multiple times, or you just have one opportunity to drill into the lunar regolith? Thanks.
Okay, let me take that first one. So if we launch tomorrow, actually we have a 4-day launch window. If we launch any of the first 3 days, our landing date is March the 6th, late morning Central Time. I'll get you the exact date or exact time once we get into orbit, but around late morning, 11-ish, late morning. And then if we launch on the last day of the window, we would land 1 day later. Either way, the mission ends around March the 16th, when the Earth actually sets and we no longer can communicate back with the Earth. There is an interesting phenomenon occurring a couple days before that where we actually will see an eclipse of the sun behind the Earth from the moon.
And this is Jackie answering your prime question. So the Prime 1 is mounted to the Athena lander. It is not on a mobile platform. It will have the ability to take one drill hole sample, but we take multiple samples across the full 1 meter profile. So we'll get a sample of regolith brought to the surface from multiple depths across that full meter, but only one hole is drilled at that location. There is no mobility associated with the drill on the lander. It is firmly attached.
Thank you for those answers. Our next question comes in from Manuel Mazzanti with Exploración Espacial.
Thank you so much. A question regarding the Grace hopper. I understand it has its own propulsion system, RCS system. My question is, does it need to relight its engines before touching down after each hop? I understand it can go 20 meters, 50 meters, 100 meters up. And then does it need like a line of sight visibility with in terms of communications? What happens with inside a crater? Thank you.
Okay, this is Trent Martin. I'll answer that question. The prop system on Grace is a hydrazine prop system. We use a burst technique. So yes, we are firing the rocket engine multiple times during a single hop, and then obviously right before we land onto the surface. We utilize reaction control system as well to help with controllability of the vehicle as it is flying, and we use camera systems and laser systems as our navigation and position GN&C system to land the hopper upright as we hop one hop to the next. Our current plan is that we would hop maybe once a day for 5 days. Each hop is a very short time frame in that 5 days. We use that day in between to plan for the next hop. Exactly where did we land in the first place? Where are we going to? Our ultimate goal is to go down into that permanently shadowed region on hop number 4 and then hop back out on hop number 5. Your question about comms is a great question. We've been looking into that. We currently believe that we potentially will have some comms even when we're out of line of sight. And I'm gonna let Thierry answer a little bit of that as well, because we believe we'll have that because of the LTE system that we have on board the hopper. We have a backup system as a UHF. We're pretty confident that would require line of sight. We're trying to stay in line of sight for each one of the hops, but obviously when you go down into the PSR, we will likely be out of line of sight. So Thierry, if you wanted to add to that, that would be great.
Yeah, thanks, Trent. This is Thierry. In general, cellular technologies work in line of sight and in non-line of sight conditions. So we do indeed believe that we will have communication capabilities to the hopper when it's in the crater in non-line of sight conditions, but we will really take the measurements and validate and confirm that. And this would take advantage of some of the multipath properties that Trent had talked about earlier from the regolith. And in general, taking measurements of the cellular technologies on the moon will allow us to really calibrate our simulation models and channel propagation models that we've developed, but taking measurements for the first time on the lunar surface allows us to really then tune these models that will be very beneficial for future missions. Thank you.
Thank you so much to everyone. We do have a few more minutes, so we want to take the opportunity to answer some of the social media questions that have come in. One of our questions is from Ricky on Instagram, who asks, how does the Prime 1 Trident drill compare to other lunar drills? So I think that's a Jackie Quinn question.
Yes, so let me talk a little bit about that. So the Prime 1 Trident drill stands out from previous lunar drills due to its ability to cut through both very hard rocks and also icy regolith. And that's a capability that differentiates it from other drill systems like, for example, the Lister drill, which is a pneumatic drill which cannot penetrate into rock. And while Apollo's human-operated rotary percussive drill and past Soviet and Chinese sample return drills utilized the rotary percussive mechanisms to core samples to 2 to 3 meters, The Trident drill is actually unique in being a robotic drill with instrumentation designed within it, and it performs in situ thermal analysis. So unlike other previous lunar drills that primarily focus on sample collection or subsurface measurements, the Trident incorporates both a downhole heater and temperature sensor to directly assess the thermal environment of the lunar South Pole. This makes it not just a drilling tool, but also a scientific instrument. Additionally, Trident is poised to be the first robotic drill deployed near the moon's South Pole and the first robotic drill from the U.S. on a lunar surface, making it a significant milestone for the U.S. in lunar exploration technology.
Thank you. Next up, we have questions about landing radar. Teacher Aaron 26 asks, how is the landing radar on the current landers different from the Apollo-era landers? And I want to add on a question for Daniel Clemens to also talk about how the Lunar Retroreflector Array can help with future landings.
Okay, this is Trent. I'll answer the question about landing radar. We do not use landing radar on Nova-C, nor do we use it on Hopper. We use an optical navigation system with a laser rangefinder. So we use the laser to tell us how far the surface is from the vehicle, and we use our optical navigation system to identify craters, recognize a path that we're flying compared to a map basically made by Lunar Reconnaissance Orbiter. We compare that map to determine our trajectory and ensure that we're headed down the right path. Once we rotate nearly upright as we begin to land, we use optical navigation and hazard avoidance systems to identify craters or rocks or boulders that could be a hazard to landing, identify a flat surface free of hazards, and land in that space.
Yeah, this is Dan Cremons from NASA Goddard. We really envision LRA as complementary to the techniques that Trent discussed in terms of both optical navigation, laser ranging, and hazard avoidance. So the LRA is obviously too small to see probably as you're coming down, but from a laser altimeter's perspective, it's going to shine extremely brightly like a lighthouse in the dark. And so if a laser altimeter, either during orbit or starting the landing descent, shines onto the laser retroreflector array, it's going to show up as thousands of times brighter than the surrounding surface. And so it will be incredibly easy to pick out that signature from the surrounding terrain. And once you have that signature, you know, along with the pointing of your spacecraft and your instrument, exactly how far away you are from the LRA, and also where on the surface, with respect to the surface, you are. And so, you know, we envision something like, you know, these could operate similar to kind of landing lights on a runway, where if you had, for example, a landing pad, or if you wanted to land next to the Athena lander in the future, for example, you could find out exactly where you are regardless of illumination conditions. So you don't need to necessarily rely on real-time optical navigation if you have one of these landing markers that you can continuously hit with your laser altimeter and use for navigation. And so we look forward to demonstrating these kinds of LRA navigation techniques in the future. And I just want to note that this type of navigation has been used for quite some time on the International Space Station, which has retroreflectors positioned around the docking port that are used for precise navigation and orientation. Thanks.
Let me add one thing that I failed to mention. Yes, we absolutely believe that things like LRA will be valuable for the future. We are also building a fleet of satellites that will have position navigation and timing capability, and we believe that in the future, just like you use GPS here on the ground, we will essentially use a GPS-like system using our satellites to land spacecraft on the moon, as well as to maneuver spacecraft, mobile spacecraft, hoppers, rovers, even positioning of astronauts as they move around on the surface of the moon, utilizing those in-space capabilities to give them a good understanding of where position is.
All right, we are coming up on time. I'm going to ask one more question from social media and then pass it to Joel Kearns to wrap us up today. This last question is also one for Jackie Quinn, and the question is from Joe on Instagram, who asks, how can M-Solo tell the difference between volatiles on the lunar surface and volatiles coming off the lander itself?
That's a good question. This is Jackie, and it really relates back to a test we did in early 2019 that was funded from Space Tech. And it's actually a unique response of the instrument capability of going to a commercial off-the-shelf mass spectrometer. So Infocon offered two different sensors, an open ion source and a crossbeam sensor. Open ion source is very omnidirectionally evaluating what gases are they can detect, whereas the crossbeam is sensitive in a specific direction. We took both of those sensors up to a vacuum chamber with soil in it up at Klein Research Center. We were specifically interested in understanding whether the sensitivity of the crossbeam, which is directionally sensitive, would be as good or sufficient enough to provide us the answers we were looking for as the omnidirectional tool, which is offered by Infocon and very, very sensitive. And the answer was we got really good sensitivity with the crossbeam. The crossbeam allows us to evaluate the evolution of gases into the vacuum of space off of the regolith in a specific field of view and sort of filter out everything that's happening around us, meaning that if there is something coming off of the lander, we are far less sensitive to it being in our field of view of analysis than if we had chosen the other alternative commercial off-the-shelf sensor from Infocon, which is a open ion source. So we made that technical decision to go with that field of view with the purpose of knowing that there might be water or other volatiles coming off of the lander that we didn't want to include in our analyses.
So this is Joel Kearns from NASA Science. Go ahead. Okay, it's Joel Kearns from NASA Science. Go ahead.
Yeah, sorry, go ahead.
Go ahead, Trent.
I was going to point out, Jackie, did you want to mention anything about the recent addition that we added to run M-Solo prior to Flying Hopper and then after Flying Hopper as well?
We can. I was answering their specific question, but I can go into that. I think one of the unique collaboration opportunities we have between NASA and Intuitive Machines is the ability to look at the molecular movement induced by the hopper. So the hopper has a fuel that it's going to use to move from hop to hop or location to location. And because of the ability of those molecules to almost ballistically translate across the lunar surface, we're able to detect them back at, we anticipate we'll be able to detect them back on the lander itself, which will provide us some really key and opportunistic data as far as it feeds forward into how do molecules on the surface of the moon behave, how far away can we see those molecules, or can we analyze for those molecules, and is there a set distance from the lander to a hop that we wouldn't be able to see? And I think that feeds forward into future missions as we go to put more and more scientific instruments on this on the different carrier services. And if those future instruments have significant environmental cleanliness requirements and, want to know if another payload that carrier is sending would influence any of their science data, that we have those boundaries and data to say, hey, when you get X distance away from the lander, we're not going to see anything of value that would inhibit another payload's operation. So as far as, understanding the long-term impacts of that, as far as future payloads and the interaction, that's going to be there. It'll help to bound some of the models that we look at, hopping of molecules on the lunar surface. And then he mentioned that Trent mentioned there's going to be an eclipse that happens. It's a fairly short eclipse, and we're actually hoping to be on for that transition. And we'll be acquiring a couple of things. We'll be acquiring the downhole temperature as it goes into the dark period, and we'll also be looking at molecular movement on the surface of the moon during that dark period. And all of that will be available as key science data in the future.
And with that, I'm passing to Joel Kearns to finish us up today.
Well, I hope you were able to hear from our opening statements and responses to the questions how excited this whole group is, scientists, engineers, technologists, industry people, and people that just want to see the United States advance on the space frontier coming up. The IM-2 lander, Athena, will go closer to the South Pole than targeted by any previous robotic mission. In addition to satisfying all the objectives you heard about today, it's going to give us our first look at the South Pole region, which is going to be really valuable for us and our partners. In addition to that, for example, the Lunar Trailblazer satellite will be in orbit around the moon, looking wider at the whole area of the moon, looking for, as Bethany Ehlmann pointed out, presence of hydrogen, oxygen, maybe water made from hydrogen or oxygen, or where hydrogen and oxygen is in lunar rocks. This is a really sophisticated mission enabled by the partnership between the government and U.S. industry. Thank you, Karen.
Thank you to everybody who is here. You can continue to find out more information on nasa.gov/CLPS, CLPS. The broadcast will be available on nasa.gov/live. And go CLPS. And I am too. Thank you so much. Bye.